Hello viewers, welcome to UN Digital Class. In today's lecture, I am going to discuss about Part 2 of SSL protocol. In my previous lecture, I have already discussed about the SSL protocol, and in that SSL protocol, I have only discussed about the handshaking protocol. Now, in this lecture, I am going to discuss about other three different types of SSL protocol. Now, let us start. First of all, I am going to discuss about chain cipher spec protocol. This protocol defines the process of moving values between the pending and active state. That means this protocol basically discuss about the process how the packet moves from the pending state to the active state. The pending state keeps track of the parameters and secrets, and the active state holds parameters and secret used by the record protocol to sign or verify or encrypt or decrypt the message. That means in this protocol there is two states. One is the pending state, another one is the active state. And the pending state keeps the parameters and secrets, and the active state keeps parameters and secrets, and those parameters and secrets are used for signing or verifying or encrypting and decrypting the message which is used by the record protocol. This is the function of the chain cipher space protocol. Here you must remember that each state holds two set of values. One is the read value, that is the read inbound, another one is the write outbound values. Now look at this figure. This figure shows the movement of parameters from pending state to the active state in our chain cipher spec protocol. In this protocol, the sender and receiver has two states. One is the active state, another one is the pending state. Before the exchange of any message, here the pending columns have values. Look at here, this is the pending column of the sender and this is the pending column of the receiver. That means in our chain cipher spec protocol, before exchanging any message, only the pending columns are filled with values. Then first the client send a chain cipher spec message to the server. After the client send this message, it moves the write outbound parameters from pending state to the active state. Look at here. Here the pending state write outbound parameters are moved to the active state. That means when the client send the message, at that timing, the pending state write outbound parameters are moved to the active state of the write outbound parameter. Then next, the client can now use the parameters to sign or encrypt the outbound message, which means here these write outbound parameters are used by the client to encrypt the message and send to the server. After the receiver receives this message, it moves the read inbound parameter from the pending state to the active state. Look at here, when the message is received by the server, then the read inbound parameters in the pending state is moved to the read inbound parameter of the active state. Then now the server can verify and decrypt the message. This means that the finished message sent by the client can be signed and encrypted by the client and verified and decrypted by the server. This is the process when the chain cipher spec message is sent from client to the server. Then next, the server send a chain cipher spec message after receiving the finishing message from the client. When the receiver or the server sends this chain cipher spec message, then the write outbound parameters from the pending state is moved to the active state. Now look at here, when this message is coming from the server to the client, then the write outbound parameter. Here this is our write outbound parameter, but in this case when the server sends this message, the write outbound parameters are moved from the pending state to the active state. Then the server can now use these parameters to sign or encrypt the outbound message. After the client receives this message, it moves the read inbound parameter from the pending to the active state. Now look at here. Here this is the read inbound parameter which are in pending state. But when the client receives this message, then these read inbound parameters in the pending state are moved to the active state of the read inbound. Now the client can verify and decrypt the message. That means after the exchange finish message by the server, both parties can communicate in both the direction. Which means here when the client send a change cipher message, at that timing the client uses the write outbound parameter to encrypt the message, and the server uses the read inbound parameter to decrypt the message. In this way, when the server send a message to the client, at that timing the server uses the write outbound parameter to encrypt the message, and the client uses the read inbound parameter to decrypt the message. This is the process how the parameters are moved from the pending state to the active state in your change cipher spec protocol. Next, we discuss about the alert protocol. Here the SSL uses the alert protocol for reporting errors and abnormal conditions. That means this alert protocol is basically used by the SSL to reporting the errors or abnormal conditions which occur during the transmission. It has only one message type and the alert message that describes the problem and its level. This alert protocol have one message, that message is called the alert message, and this message defines the problems or errors which occur during the transmission of packet. Now look at this table. This table shows the alerts defined for SSL in our alert protocol. Here the value 0 which describes the close notify, that means the sender will not send any more message. This is the notification message which is displayed by our alert protocol. Then next 10. Here this is the unexpected message, which means an inappropriate message is received. The next one is the 20, which is the bad record MAC. That means an incorrect MAC received, which means when an incorrect MAC received, at that timing the alert protocol displays this message. Then next 30. Here the 30 means decompression failure, unable to decompress appropriately, which means when our data or packet is transmitted, if there is any decompression failure, then our alert protocol displays the message that is decompression failure, or it displays the value that is 30. Then next 40. This value means handshake failure, sender unable to finalize the handshake, which means during the transmission if any handshake failure occurs, then the alert protocol displays the message value that is 40. Then next 41 means no certificate. Client has no certificate to send, which means when the client sends no certificate, at that timing this message will be displayed by our alert protocol. Then next 42 bad certificate. received certificate corrupted. That means when the receiver receives a corrupted certificate, at that timing this alert message is displayed. Then next 43 means unsupported certificate. That is the type of received certificate is not supported, which means when the receiver receives a certificate from the sender but that certificate is not supported, at that timing this alert message is displayed. Then next 44, that is the certificate revoked. Signer has revoked the certificate. That means when the signer, that means who signs the certificate, revoke that certificate, at that timing this alert message will display. Then next 45, that is the certificate expired, which means when a sender sends a certificate to the receiver but that certificate is expired, at that timing this alert message is displayed. Then next 46, that is certificate unknown, which means if there is a certificate which is used by the sender or receiver but that certificate is unknown, at that timing this alert message is displayed. The next 47, that is the illegal parameter, which means an out of range or inconsistent field. This is all the alert message value which is displayed by the alert protocol during the transmission of packet in your network. Next one is the record protocol. Here the record protocol carries message from the upper layer. That means from the handshaking protocol, chain cipher protocol and alert protocol. Next, the message is fragmented and optionally compressed. A MAC is added to the compressed message using the negotiated hash algorithm. That means this record protocol carries the message from the upper layer and that message is fragmented and optionally compressed, and it holds a MAC which is added to that compressed message and then it uses a hash algorithm. Next, the compressed fragment and the MAC are encrypted using the negotiated algorithm. That means the message which is compressed and fragmented, that message and the MAC value both are encrypted by using the algorithm. Then finally the SSL header is added to the encrypted message and the process at the receiver is the reverse, which means in this record protocol, first this record protocol takes the message from the upper layer. After that this message is compressed and fragmented. After compression this message uses a MAC value and this MAC value and the fragmented message both are encrypted by using some algorithm. After that the SSL header is added to that encrypted message. This is the process which happens at the sender side. At the receiver side the reverse process is happened. That means at the receiver side, first of all the message is decrypted by using the decryption algorithm. After that it generates the MAC value and the fragmented message. Then from that fragmented message and the MAC value it generates the original message by using some defragmentation and the decompression. This is the process which occurred at the receiver side. Now look at this figure. This figure shows the processing done by the record protocol. In this figure, the record protocol uses the fragmentation and it also uses the encryption by using some encryption algorithm. Then it generates the SSL payload. Now look at this figure. In this figure the payload from the upper layer protocol. That means this is the message which is coming from the upper layer or the application layer. Now this message is fragmented. After fragmentation this message is compressed by using some compression function. Now look at the compressed message. In this compressed message, it uses a hash algorithm or hash value. This hash algorithm takes the compressed message and the write MAC secret. Then it also takes other values. After that it generates a new MAC value, and now this new MAC value is added to our compressed message. When this MAC value is added or appended to our compressed message, after that this compressed message and the MAC value both are encrypted by using some encryption algorithm. Here it uses the write cipher secret to encrypt the compressed message and the MAC value. After encryption, it produces the encrypted fragment. When the encrypted fragment is produced, then this encrypted fragment is called as the SSL payload. After that, it combined with the record protocol header. That means when the SSL protocol payload is generated, this is appended with the record protocol header. This is the process which is done by the record protocol. Now look at here, this figure shows the encapsulation in our record protocol. Here this field is the protocol field, this is the version of our protocol, this is the length, then this is the compressed fragment, that means our compressed message, and here this shows the MAC value. This is all about the processing which is done by our record protocol. Next, fragmentation and combination. At the sender, a message from the application layer is fragmented into blocks of 2 to the power 14 bytes, with the last block possibly less than this size. That means at the sender side, when this protocol receives the message from the application layer, that message is fragmented into blocks of 2 to the power 14 bytes. Then next, at the receiver, the fragments are combined together to make a replica of the original message. That means at the receiver side, the fragmented messages are combined to make a replica of the original message. Here, you must remember that at the receiver side, the message which is coming from the application layer are fragmented. But at the receiver side, these fragmented messages are combined to form the original message. This is all about the fragmentation and combination process which happen at the sender side and the receiver side respectively. Then next, compression and decompression. At the sender, all application layer fragments are compressed by the compression method negotiated during the handshaking. That means at the sender side, all the message which coming from the application layer are compressed by using the compression function. Then the compression method needs to be lossless. That means when the sender uses the compression function to compress the message which is coming from the application layer, that compression function must be lossless, because there is no loss in our message during the compression. For this reason, we use the compression function which must be lossless. Then next, at the receiver, the compressed fragment is decompressed to create a replica of the original message, which means in this case the compression happens at the sender side, which compress the original message by using some compression function. But at the receiver side, it uses the decompression function to decompress the compressed message and create the original message. This is the process of compression and decompression. Next, signing and verifying. At the sender, the authentication method defined during the handshake creates a signature. That means at the sender side, the signing is happened, but at the receiver side, this signature is verified. That is called the verifying. Next, encryption decryption. At the sender, the compressed fragment and the hash are encrypted using the cipher write secret. That means at the sender side, the compressed fragment or the compressed message and the hash value both are encrypted by using the cipher write secret. But at the receiver side, the received message is decrypted using the cipher read secret, which means here the encryption of the fragmented message and the hash value is performed by using the cipher write secret. But at the receiver side, the message is decrypted by using the cipher read secret. This is the process of encryption and decryption in our record protocol. Then next, farming and defarming. After the encryption, the record protocol header is added the sender and the header is removed at the receiver before decryption, which means in farming, after the encryption at the sender side, the record protocol header is added, but in defarming, the header is removed at the receiver side before decryption. This is all about the change cipher spec protocol, alert protocol and the record protocol. Here you must remember that the change cipher spec protocol is basically perform the function by using the two states, one is the pending state, another one is the active state. And the alert protocol always gives the alert message if there is any issue or any problem happen during the transmission. And the record protocol is nothing but it always takes the message from the application layer, then it processes it and it send it to the transport layer. This is all about these three protocols. If you have any doubt regarding these three protocols, then you can ask me through comment. I will reply you and discuss about your doubt. Thank you for watching.